Welcome to China Latest News. Chinese companies, universities, and government institutions are increasingly barred from accessing exports of American, Dutch, and Japanese machinery used to make the microchips essential to high-tech industry. But they are racing to develop a homegrown extreme ultraviolet (EUV) light source that can help etch electronic pathways on the most advanced silicon microchips. An EUV light source is but one part of a deeply complex EUV machine, a part that only Cymer, the San Diego affiliate of Dutch toolmaker ASML, has succeeded in putting together. An EUV machine enables its owner to manufacture the kind of wafer-thin microchips that Apple puts in its latest iPhones and OpenAI uses to power ChatGPT, the artificial intelligence-powered language model that can generate human-like text. Cymer's EUV light is generated by shooting a high-energy laser at molten tin and then focusing the resulting light in a beam used to carve minute circuitry patterns onto wafer-thin silicon chips. Such EUV lithography machines, and the light sources they rely on, are an important piece of the puzzle of technological independence China is trying to put together to climb the tech value chain by making the kinds of chips that will power future tech such as AI and quantum computing. Under pressure from Washington, the Dutch government never has allowed ASML to ship an EUV lithography machine to China. The most advanced ASML EUV machines in commercial use today cost the companies who buy them around $150 million. The next generation of machines, set to ship in 2024, will cost upward of €300 million, $328 million. Market research firm Mordor Intelligence estimated the value of the EUV lithography market at $11.5 billion in 2023, with the broader semiconductor equipment market valued around $123 billion. As evidence that the future tech competition is heating up, Chinese patent records show that in the past year Tsinghua University, the MIT of China, Nanjing University, the Chinese Academy of Sciences, and a firm called Specreation headquartered in Hefei, Anhui Province, all filed patents for EUV light source technology. Experts say they all have their work cut out for them. The challenges of making EUV light sources that can function within a stable and long-term viability system are enormous. Paul Triolo, Associate Partner for China and Technology Policy Lead at Denton's Global Advisors ASG, a Washington, D.C.-based consultancy, told the China Project. Even if a firm is successful in making an EUV light source, Triolo said, it can be challenging to get it to work within existing semiconductor manufacturing processes. A little help from the U.S. While U.S. laws have curtailed exports of technology for commercial production of top chips, some technologies used for fundamental research underpinning semiconductor development continue to flow across the Pacific. In some cases, the Chinese organizations working to develop their own EUV light sources have purchased cutting-edge laser technology from KM Labs of Boulder, Colorado. On October 21, 2022, Huazhong University of Science and Technology in Wuhan, Hubei Province, Central China, purchased an EUV light source machine from KM Labs, according to reporting in the Chinese press citing government procurement records. KM Labs sells its EUV light source machines through distributors around the world, including through a firm called Transientech in China. KM Labs, along with its Belgian partner IMEC, is at the cutting edge of a chip-making technology called high numerical aperture (NA) lithography that has certain advantages over that used by Cymer and ASML. KM Labs told the China Project that its EUV light sources were not suitable for use in EUV semiconductor lithography, but were being used in research relevant to EUV lithography, and that all of its exports were in compliance with current U.S. law. While KM Labs's EUV light source isn't used directly to make chips, a press release from the company acknowledged that its collaboration with IMEC is aimed at understanding EUV lithography fundamentals that will be used to manufacture next-generation semiconductor chips. A separate KM Labs presentation noted that a piece of equipment it makes called a XUUS high harmonic generator is available for sale in China and is in demand for semiconductor applications. Huazhong University is not the only Chinese buyer of KM Labs technology, according to a press release on Transientech's website. Peking University, Tsinghua University, the Chinese Academy of Sciences Lanzhou Institute of Chemical Physics, and Shanghai University of Science and Technology also bought tech from the Colorado firm. We are proud to provide the most advanced EUV ultra-fast pulsed laser light source and localized technical support to the top research teams in China. Transientech's website read in Chinese. A long road ahead. Despite Beijing emphasizing the importance of China's technological independence in chip-making, the country has a long way to go before it can produce an EUV light source system suitable for lithography, let alone the much more complex EUV lithography machine itself. Triolo said that China faces a difficult road ahead in acquiring the critical materials required to make and use an EUV light source at commercial scale. While China could have a workable light source for EUV within 2 years, the major question mark remains systems integration, supply chains, other critical systems such as optics, and other adjacent areas, he said. Other industry observers told the China project 2 years was an optimistic prediction. Dylan Patel, head of Semi-Analysis, a boutique semiconductor research and consulting firm, said it would likely take China much longer to develop the technology. Besides Simmer's EUV light source for commercial chip lithography, Japanese firm Gigaphoton has produced a less advanced, deep ultraviolet DUV light source. A September 2022 report from China's National Intellectual Property Administration, CINIPA, pointed out that an EUV light source is made up of several different technologies, and that thus far China has been unsuccessful in developing the gases, light collectors and amplifiers, and magnetic field tech necessary for a commercially viable EUV light source. Chinese electronics giant Huawei recently entered the chip lithography space, when in November 2022 it filed a patent for EUV technology. Huawei also has invested in leading Chinese light source firm RS Laser Optoelectronics, which provides the light sources for the lithography machines made by Chinese firm Shanghai Microelectronics. Huawei isn't alone. The CNIPA report also noted all those who have filed for patents for EUV light source tech. Harbin Institute of Technology ranked first with 13 patents, followed by Huazhong University with 5, and Chinese chip foundry Semiconductor Manufacturing International Corporation, SMIC, and the Shanghai Institute of Optics and Fine Mechanics, with 3 each. Working around EUV. Even as China works to develop EUV technologies, some of the country's firms are searching for workarounds that will produce the same results without having to create the advanced tech. One shortcut to higher levels of efficiency is through advanced packaging techniques for chips after their circuits have been etched in the lithography process. As the transistors on circuits shrink in size, a focus has grown on increasing computing efficiency by stacking chips on top of one another. Chinese firms, including Huawei, are looking at the advanced packaging issues intently, and have very capable companies in this space, Triolo said. China is farther ahead in this sort of advanced packaging than other countries in the semiconductor supply chain. Still, firms outside China, such as TSMC of Taiwan, Samsung of South Korea, and America's Intel also are working hard at advanced packaging. Chinese firms also are pushing the less advanced DUV machines to their limits in order to achieve results usually associated with top EUV tech. Industry observers were surprised to find that SMIC was able to produce 7-nanometer chips last summer, despite U.S. export restrictions designed to prevent Chinese firms from acquiring the machinery to achieve results smaller than 10 nanometers in size. Industry observers say SMIC could go even lower than was previously thought using the tech available to them. Patel told the China Project that Chinese firms can get to 5 nanometer, using DUV tools that can be shipped to China legally by Dutch firm ASML. Chinese tech firms and university research teams are working to create a commercially viable EUV light source, a critical piece of the machines used to make the advanced chips that will power future tech such as artificial intelligence and quantum computing. As the US and its allies bar exports of key technology to China, Chinese scientists and engineers may be better served by focusing on less difficult ways to increase the quality of homegrown semiconductors.